Good morning, geometry. So today, what we're going to be working on is the end of the week 7 notes. So fortunately, there's only one page, and in week 7, or with these, what we're learning about is special segments and triangles. With these special segments and triangles, there used to be a lot more that we had to do. There used to be a lot of like calculations and stuff. But because we're doing this virtual learning stuff, they took some stuff out of the curriculum. So now we only have to be able to identify them, which is what we're going to be doing today. So we have 4 types of special segments in a triangle. And the first one is going to be an angle bisector. And we've learned about angle bisectors before. An angle bisector is just a segment that is going to bisect a certain angle. And bisect means split it in half. So we can see this segment PL is bisecting this angle P, and we can tell it's bisecting it because it has just one little congruency marker. And to identify angle bisectors, that's going to be the giveaway, just the congruency marks. So we're going to look for these. If I could spell, well, I can spell, it's just my handwriting's bad on this. Look for congruency marks. And I'll say angle congruency marks because we see there are the tick marks that identify if we have, there are the tick marks that identify if we have congruent segments, or the little arc things that identify if we have congruent angles. So look for angle congruency marks. That will tell you if we have an angle bisector. The next type is going to be a perpendicular bisector. We've also learned about perpendicular bisectors before. So a perpendicular bisector is a segment drawn inside a triangle that is both perpendicular and bisects the side of a triangle. So we can see that this segment is perpendicular because it has a right angle, and it is a bisector because this segment AD and this segment BD have those tick marks, which tells me that they're congruent. So it split that segment AB in half. So the things we're going to be looking for to identify if it's a perpendicular bisector are either so we want to see the tick marks, because that will tell me that, hey, it's congruent on both sides. Or sometimes it'll just say D is a midpoint. So if you see a problem that says like this point is a midpoint, then you know that it is bisecting it. That tells me it's a bisector. The tick marks or the D is a midpoint tells me it's a bisector. To tell if it's a perpendicular bisector, you must see the little box thing there. So you must see box, which I'll also say right angle. So you must see the box in a right angle. That will tell me it's a perpendicular bisector. And even though all the examples here just have like one drawn through, we can have 3 separate perpendicular bisectors on a triangle, because there's going to be a perpendicular bisector on this side AC and a perpendicular bisector on this side BC. Likewise, angle bisectors, there's going to be something that bisects angle P, as well as a segment that bisects angle Q, as well as a segment that bisects angle R. Okay, So on to the next one. The next one is a median. And we've heard the word median before in math when we talk about like mean, median, mode, range. A median is a segment in geometry drawn inside a triangle that connects a vertice of a triangle to the midpoint of the opposite side. So it's going to be like an angle bisector or a perpendicular bisector because it's going to be bisecting one side. We can see that this one bisects this side AB. But what's different about the median is that the perpendicular bisector does not have to go through an angle on that triangle. It doesn't have to go through a vertice, whereas the median does. And the perpendicular bisector is a right angle, median not always, or not often really. So we have to see the same stuff here. So I'm going to copy this. So we need to see either tick marks or it's going to say D as a midpoint to identify that, hey, this is splitting it in half. But with this one, well, on the last one, it had to be a right angle. On this one, it has to, so it must go through opposite vertex. So we see that this median, this CD, goes through that point C. It bisects the segment AB and it goes through C. And the fourth one that we're learning about is the altitude. And the altitude is going to be a segment drawn from a vertice of a triangle that is perpendicular to the opposite side. So perpendicular bisector bisected it. A median, a perpendicular bisector was perpendicular and bisected it. This one is going to be perpendicular, but it goes through one of the vertices of the triangle. I cannot speak today. So we have this altitude, which can be inside, outside, or on the triangle, depending on what kind of triangle you have. So we can see here, this first one, the altitude is this red line right here. And it goes through the point B, and it forms a right angle. And that's how we know that it's an altitude, because it goes through a certain point and forms a right angle. And this one is inside the triangle. And we'll notice this first triangle, ABC, is an acute triangle. So if it's an acute triangle, the altitude will be inside the triangle. Next, we have this triangle ACD, and this line here, this AB, is the altitude because it goes through the point A and it is perpendicular to this CD. So even though it wouldn't go through CD, they extended CD to make it work. And then they were able to put in that right line, or right angle. I'm going to do that, yeah. And we can see that ACD, this triangle here, is an obtuse triangle. So with an obtuse triangle, the altitude will be outside. The altitude is the only one that could be inside, outside, or on the triangle. All the others are going to be inside the triangle. And the third type of altitude we would see would be on the triangle. So let's see, we have this triangle ABC, and the altitude here is going to be this segment AC. And AC is also a segment on that triangle. So that's what I mean by on the triangle, because this is already a right triangle. So the altitude of this right triangle, it goes through the point A, and it's perpendicular to this segment BC. So if it is a right triangle, it is on the triangle. And the altitude, as I was saying before, it's perpendicular but not necessarily a bisector. And we're going to see the only two examples in which it would be a bisector right now. So we have special segments in isosceles and equilateral triangles. So the first one we have here is an isosceles triangle. Okay, the first one we have here is an isosceles triangle. And I'm going to go ahead and mark these sides as being congruent. So that tells me that it's isosceles. And I'm going to, from my vertex angle, remember the vertex angle is the angle where the two congruent sides meet on an isosceles triangle. So I'm going to draw in a segment there. So this segment goes from that vertex angle to the segment at the bottom there. And with an isosceles triangle, it will always meet at a right angle. Only with an isosceles triangle, if it comes from the vertex angle. If it comes from one of these two angles at the bottom, it's not going to be a right angle. So yeah, if it comes from the vertex angle, then yes, these rules are going to apply. If it comes from one of these angles at the bottom, these rules are not going to apply, and you're just going to treat it like it's a scalene triangle. So it met at a right angle. And since it met at a right angle, where's my, okay, there. Since it met at a right angle, that means it's going to be an altitude. And another thing is that this segment, I'll use a different color actually. It split this angle, this vertex angle, in half. So it's not only an altitude, it's an angle bisector. What else can we say? So since it is an angle bisector and is an altitude, wait, what else? Sorry, I'm trying to think. Oh, I remember. I remember what I was about to say. Okay, so another thing is that it's going to split this side across from the vertex angle, the base, into two congruent segments. So, since it is perpendicular and it splits that into two congruent segments, it's a perpendicular bisector as well. And finally, since it is perpendicular, or not perpendicular, since it splits this into two congruent segments, and since it goes through the vertex point, that means that it is also a median. So on an isosceles triangle, if it goes through the vertex angle, then it is all 4. If it doesn't go through the vertex angle, then you'd have to go through the process. And I will be leaving a flow chart on Schoology, which you should see in the same folder where you find these notes, which would be the week 8, Monday 10/19 folder. But yeah, there's in the week 8, Monday 10/19 folder, there's like a flow chart that'll tell you how do I identify all this stuff. So you should use that on the assignment that you're doing after this, if you need to. And then the last thing we have is an equilateral triangle. Today's not my day. So with an equilateral triangle, we know that all 3 sides and all 3 angles are going to be congruent. So if I have a segment that is going through one of the points and meeting another side, at least one of these special segments, since an equilateral triangle is a type of special isosceles triangle, which we talked about in a previous video, then it is also going to be all 4. So I'll just copy and paste again. I'll bring it over here. Okay, so it will also be all 4. Sorry, I just need to like slow down and take my time with this. Okay. And that's if it's going through any of the 3 on an equilateral triangle. Only with equilateral triangles though. So if you see it identified as equilateral and it is one of these special segments, you can identify it as all 4. Now, the last thing I would like to say about these before I set you guys free is that with these 4 types of special segments, I said that you can draw the special segments through any angle, or you can draw 3 of them on any given triangle. So like with this one, I would be able to draw an angle bisector about there, and I'd be able to draw an angle bisector about there. One thing that's neat about all 4 of these is that when I draw all 3 on a certain triangle, they're all going to meet at the same point. So I'll use a different color here. Angle bisectors are going to meet at what is called an incenter. That's way too big. So it's called the incenter. So if you draw all 3 angle bisectors on a triangle, they will all meet at the incenter. If you draw all 3 perpendicular bisectors on a certain triangle, they will meet at what is called a circumcenter. If you were to draw all 3 medians on a triangle, they would meet at what is called a centroid. And if you were to draw all 3 altitudes on a certain triangle, they would meet at what is called an orthocenter. And I'm not positive you have to know those, or the names of those 4 points, but I do know that you need to be able to identify these 4 types of special segments. And to be honest, I always get like median and altitude mixed up, and perpendicular bisectors sometimes, even though it's kind of self-explanatory. So if you're not great at this, that's okay. That's why I posted the flow chart. So please use it, because I did post it to Schoology, and you should be able to find it relatively easily, and it should really help you with the assignment coming up, because the assignment coming up is pretty easy. But other than that, I have nothing else for you guys today. I will see you guys tomorrow.